I'm presenting today on behalf of myself and my co-author, Just Sebrian, and I'm going to demonstrate a dashboard app that displays inventories of some large-scale deepwater habitats in the Gulf of Mexico. So inventories help us answer questions about what habitat types exist, where they are, how much is there, and we need this information so that we can then understand why marine life exists, where it does, and why, and predict where it may exist in the future. So it can also help us set conservation and restoration targets and to inform where to sensibly site infrastructure and extract resources. And so these questions apply to management needs at multiple scales, from global to regional to very local. And so one of the data sources for this project is the Global Seafloor Geomorphic Features Map that was produced by Grid Arendal, and it's available in the Esri Living Atlas, and it describes geomorphic features with commonly used terms. But this project started out as a demonstration of the geoform component, benthic depth zone modifier, and regional settings of the Coastal and Marine Ecological Classification Standard, or CMEX. And I wanted to test out how CMEX would work on the Grid Arendal map. And so I was really excited, though, when Esri released dashboards, because sometimes it's difficult to explain why you might want to apply CMEX to an existing data set. So CMEX is essentially a catalog of terms and definitions that describe benthic habitat. However, the terms are arranged hierarchically in thematic components shown over here on the right, and these nest spatially within the biogeographic and aquatic settings, which unify the individual units of the components within the broader regional to global context. So rather than simply being a vocabulary, CMEX also provides a framework for organizing data. And now I'm going to move over to the dashboard, and I hope that goes a little more smoothly than the PowerPoint presentation. Can you see my screen now?
Yes, we can.
Okay, great. So in addition to the Grid Arendal geomorphic features data set, I also use bathymetry to derive polygons for the CMEX aquatic settings and the benthic depth zone modifier units. So right here, this map layer is showing the aquatic setting. I can click on a point, get this pop-up here. These pop-ups are a little more exhaustive than what most projects would require, but I also wanted this application to be instructive, so I'm showing all the details of the CMEX framework, including all the unit levels and codes, and I've calculated area for each unit. But back to the aquatic setting over here in the legend, you can see I'm just displaying the lowest level of the hierarchy here, which is the tidal zone. And so we have these 3 tidal zones within the Gulf of Mexico: marine nearshore, offshore subtidal, and marine oceanic subtidal. And then for the benthic depth zones, benthic depth zones are spatial modifiers that describe major divisions in depth that represent zones of environmental influence on biota. And you can see these 5 modifier values here, and also all of the details about the modifier and where this exact unit is situated. And so the CMEX biogeographic setting uses marine ecoregions of the world boundaries and data. So that's an existing data set that I also used. And you can see here, there are 5 ecoregions in the northern Gulf of Mexico large marine ecosystem. And here, all the different levels of the hierarchy are represented. Again, I'm just showing the ecoregions, which is the lowest, most granular level of this classification in the map layer. And so all of those attributes and all that information has also been added to each of the geomorphic units, each of the geomorphic features as well, so that they also show the depth zone and settings for where they're situated. So this is a point on the continental rise, which is a physiographic setting, and you can see the various environments here, as well as the bathy benthic depth zone, and the ecoregion in the northern Gulf of Mexico, a marine oceanic subtidal environment, a rather aquatic setting. I'll turn on a couple of more layers here, and we can take a little bit of a look at those. And let me just zoom into this canyon to sort of demonstrate here. So a submarine canyon is a physiographic setting. I'm distinguishing between two types, shelf incising and blind canyons there. This unit that is selected here for this canyon is showing that it's on the continental slope in a Benthic depth zone, but canyons can be very large features, and so they can span depth zones as well. So we have a portion of this canyon that's in the Benthic depth zone, and up the very top, with the shelf incising canyon, also in a circulittoral depth zone. Let's see, and I wanted to, zoom back out. And I have these layers on. So again, we also have basins of different types. There's a shelf basin. These are basins on the slope, and these actually become geoform units instead of physiographic settings. But anyway, those are more CMEX details. But I think I'll move over now to display these basic inventories that I've been able to derive once I was added the CMEX vocabulary and framework to the grid Arundel data. I've been able to combine the data from different sources and generate these basic inventories, and these reveal patterns and distribution of geomorphology in their associated environments. So I've kind of done a little card for a continental shelf, slope, rise, and abyssal plain, and these show the area of a continental slope in a Floridian Benthic, Floridian circulittoral, and so on and so forth, and you get the picture. And so that's basically the same breakdown for each of these. And then, you can also ascertain some other patterns, like with the shelf basins, which are located here on the map. We can see that there's very few in the northern Gulf of Mexico, circulittoral depth zone, but in the southern Gulf of Mexico, there are very many more of those. And if we go to the slope basins, we can see that those are mostly present in the northern Gulf of Mexico and Benthic waters. And looking at these other basic inventories here for other features too, submarine canyons and scarps and so forth. And so, of course, with continued seafloor exploration and mapping, we'll get higher resolution data, and with that, more accurate information, and then we'll be able to generate more informative maps. But that work's being conducted by so many different organizations in discrete geographic areas. So it's good to have a framework for bringing the data together in this way. And then being able to generate these inventories, I think, demonstrate why we'd actually want to be able to do that. And so that's all I have today. Thank you.